Okay, so I kind of wanted to understand some of the math behind the transmission of coronavirus versus flu. I heard a lot of videos. One guy in particular said coronavirus we could and possibly infect 59,000 people, a layer of 10 transmissions deep, and it just seemed like a huge number. So I want to kind of look at it. So I kind of dug in a little bit. The number we're looking for is assigned is called rho, and it's a number they assign to how infectious a disease is or how easily it is to transmit. And it comes out with a number that is basically the number of people you can be expected to infect. So what they said the rho for the flu is 1.3. You're gonna have to excuse my poor writing because I'm writing sideways, whatever. So 1.3 is not an easy number to do the math on, right? So what I figured we'd do is we'd start a little more simple and kind of explain it, okay? So if Bob here infects one person, right? Then that person infects one person, and then that person infects one person, and then that person infects one person, right? So we've got 5 people here in total that have been infected, right? Because it's one. It gets a little bit more complicated when you get into 2 people, right? So my little math assistant here is going to help me out, okay? So we start here, and Bob infects 2 people, okay? So that's one layer, okay? So these 2 people now have the virus, whichever one it is, whatever. And then each one of these 2 people infects 2 people. And so how many are sick now, Zach?
There would be 4.
Okay, so we got 4 here, right, perfect. Okay, so now each one of those people is going to infect 2 people. So how many does that lead us to now, Zach?
8.
4, 5, 6, 7, 8. Okay, so we're at 1, 2, 3 layers in. Okay, let's do one more. How many we got now?
We got 16.
16. Now, this is an easy number to get to. It looks like a lot, but it's not. So each one of these is just a multiplication problem, essentially. Okay, so you've got your 2 times 2 more times 2 more times 2 more. Okay, so we've got 2, 4, 8, 16, 32, 64, etc. So if a disease has a rho of 2.0, okay, which is one of the lower estimates of coronavirus, what I have found from the CDC, it had a rated rho of 2 to 2.5, not 3 like the guy in the video said. So I'm going to go with what the CDC said. So if you have a rho of 2.0, okay, and you go out 5 layers, right? So we've got 2 times 5, Zach, right? We've done it out 5 times, and so we're at 64, right?
Mm-hmm.
Okay, so we've got 64 people that we infected. The problem with that calculation is that it doesn't include how many other people were infected along the way, right? So if you look at your first guy, and he did 2, and then they each did 2, you think, okay, I've got 4, right? So it's 2 times 2 is 4. But I actually have 6 because these first 2 guys I infected. So when you get to the 4 layers in where they had 16, what we actually had was, I think it was 30, was it 32? No, when we had one more, we had 32 people, we actually had 62 people infected total, if you summed everything up. So quickly, I want to explain why the coronavirus is more infectious than the flu. Okay, so the rho for the flu is 1.3. The rho for coronavirus is 2 to 2.5. Okay, so if we take that out 5 layers, okay, we're gonna go 5 different runs of infection. For the 1.3 with the flu, you're actually going to infect 20 people total, right? Okay, so now if we do that for a rho of 2, I'm not even going to look at the 5 layers or the 2.5 because again, I'm not trying to be crazy. So Zach, so we do the 2 times 2 is
4.
right? Alright, so we've got 4, okay, times 2 again.
8,
Okay, times 2 again is.
16,
Okay, so we've got the 2 that led to there, so we're at 4 layers. One more layer. How many we got now?
32,
32. Okay, 32 plus 16 is?
48,
Okay, plus 8. 56 plus 4 is?
52,
I don't know how you got to 52, but the number's 60.
uh-oh.
But it's okay. It's all good. We're going to get there. So we have infected 60 people at the same amount of transmission. That curve goes exponentially higher as you go out to 10. If you went out to the 10 layers like the expert did who said the 59,000, and you use the same math he did, you end up for a row of 2.0 infecting 1,024 people. With the flu, that would have been a number much closer to 40. I'd have to do all the additions to get the correct number. The number he was using was 14. Again, he's not adding all the in-between people, he's only adding the end number, so it makes the low number seem really low and the high number seem really high. The two kind of meet a little bit in the middle. Do your own research, do your own math, and we'll keep doing some for you as well.